Hey there, hope you had a great day. We're still in lesson 1.3. We're going to move on to the additional concepts covered in that section. And today our objective is I will learn to distinguish between an expression and an equation. I'm going to figure out the difference there and then review the concepts of identifying solutions of equations and identifying solutions from a set of values. All right, so we are not going to actually be solving today. We're going to be plugging and chugging and checking numbers. All right, here we go. Okay. Again, with some definitions, because knowing what we're talking about is very, very important. An equation. An equation is a statement. Oops. An equation is a statement that has an equal sign. Okay, it's a statement indicating that two expressions are equal. It must, for it to be an equation, it must have an equal sign. If you have an equal sign, you have an equation. Right? Solving an equation says that you are finding the value or the values of the variable that make the equation true. You're finding a value that makes the equation true. A solution is the value that makes the equation true. Solutions are what you find when you solve an equation. Solutions are what you find when you solve an equation. We want to keep straight in our mind the difference between an expression and an equation. Expressions have numbers, letters, and operations, but no equal sign. Expressions don't have equal signs. An equation has numbers, letters, and operations, and has an equal sign. Equations have equal signs. So if you have an equation, you have an equal sign. All right, the next thing we're going to do is we're going to determine if a given value is a solution of an equation. This is just plug in, simplify both sides if needed, one side or both, down to a single number, and if you get the same number on both sides of the equal sign, then it is a solution. This is shorthand for solution. I just couldn't get it to fit for some reason. Solution. Okay? So let's start with A. We want to determine if 7 is a solution to 5p plus 1 equals 36. So my first thing I do is I plug it in. So I have 5 times 7 plus 1. And I want that to equal 36. I'm checking to see if that does. All right? That's a question mark. I have to do multiplication on this side first. So 5 times 7 is 35 plus 1. I want it, does it equal 36? And then 5 plus 1 is 36 equals 36. So yes, it is a solution. Yes. 7 is a solution. Okay, now we want to move on to example B. 9m minus 6 equals 32. Is 4 a solution? Well, we're going to plug it in. So I'm going to have 9 times 4 minus 6, and I want that to equal 32. 9 times 4 is 36 minus 6, that's a 6. Notice how I'm carrying this one side, I'm just carrying it down, okay, because there's nothing to simplify over on that one side, all right? Okay. Now 36 minus 6 is equal to 30. Whoops, sorry. Oops, let's erase. So now I have 36 minus 6. 30 does not equal 32. So 4 is not a solution. That would be no. Why don't you hit pause and try C and then come back and see if you got it right. Okay, welcome back. I'm checking the value of 1 in 5m plus 2 equals 7. So I'm going to plug in 5 times 1 plus 2. 5 times 1 is 5 plus 2. Does this equal 7? That's what I'm checking. Remember, I'm just carrying this side down. Notice how I just carry it down. And then I end up with 7 on the left side, and then equals 7. Yes, 1 is a solution. Now, maybe you tried D on your own, but we're plugging in 1/5. Don't be alarmed. It's okay. We can do this. We know how to handle fractions, all right? I have 6 times 1/5 plus 4 times 1/5 plus 9 equals 11. So 6 times 1/5, remember I just multiply my tops together, right? So I have 6, I'm going to move over here so I don't run into my controls. So I have 6/5 plus 4/5 plus, now I'm going to go ahead and write 9 in terms of fifths. So in order for 5 to be on the denominator, because right now there's a 1, I have to multiply 9 by 5. So that gives me 45 fifths. And I want that to equal 11. All right? 6 plus 4, all my denominators are the same, so I just add my tops. 6 plus 4 is 10, plus 45 is 55 over 5. Does that equal 11? Yes, 11 equals 11. So 1/5 is the solution. I'm going to stick it in here. Is a solution. Because I got it to check down there. You try E, F, and G and come back and see if you got it right. All right, welcome back. I'm going to plug in 13 to see if it is a solution. So I have 2 times 13 plus 3 parenthesis 13 minus 2, and I'm checking to see if that equals 14. Remember, this is like a question mark, okay? All right, so I'm going to start inside my my parentheses. So I have 2 times 13 plus 3 times 11. That's a times. And I want to see if that equals 14. Okay? So I have 2 times 3, I have to do multiplication first, is 26 plus 3 times 11 is 33, okay? And I know that that's not going to equal, because 59 does not equal 14. So 13 is not a solution. All right? For example F, I'm going to plug in the 4 and simplify this side. So I have 3 times 4 squared minus 2. And I want that to equal 46 when I'm done. I have to do my exponent first. So I have 3 times 16 minus 2. And I'm checking, remember this is a question mark, if that equals 46. Now I have to do my multiplication first. So then I have 48 minus 2 equals 46. And lo and behold, I get 46 equals 46. You see how it checks? All right. We've learned this as checking our solution. All right. We're checking to see if this is a solution. So 4 is a solution. G, we have fractions. Let's not be alarmed, okay? I'm going to plug into the top, and I'm going to plug into the bottom, and then I'm going to simplify the top and bottom separately. So I have 1/3 plus 4, and then I have 2 minus 1/3. And I want that to equal 13/5. Okay, 1/3 plus 4. Well, I want to get a common denominator up here. All right, so I'm going to say that is 1/3 plus, if I want to convert this into thirds, I need to multiply 4 by 3. 12/3 divided by, now I have to make 2 into thirds, so that's 6/3 minus 1/3. So I get 13/3 over 5/3. Whoops. Okay. Now I know this is getting cramped here. I apologize for that. My pen is just not quite narrow enough. So now to solve this, I'm going to go 13/3 times, instead of writing 3/5, I'm going to flip it, and that is, this is 5/3. Instead of 5/3, I'm going to write 3/5, and these cancel, and I get 13/5, which is what I wanted my answer to be. All right? It's 13/5. So this is yes. 1/3 is a solution. Now we're going to combine what we learned yesterday about translating words and finding solutions. So today when we translate words, we're probably going to be making equations. Just a review, and I added a couple different, a couple more keywords. Added to means you add. These we talked about yesterday. I just put this in here to help you. And then whenever you see the phrase is, or, let me go to my highlighter. Whenever you see is or the same as, that always means put an equal sign in there. Insert an equal sign. Write each word phrase into an equation and find the solution from the set. They don't want us, I know we've solved linear equations before, but they want us to plug and chug from the set that they give us. All right? The sum, okay, that's nice, of a number and 4 is, whenever you see is, that translates to equals x. So we have x plus 4 equals 6. What number do we have to add to 4 to get 6? Well, that's 2. So our solution is 2. B is 9 more than 5 times a number is. Well, there's is, 49. Okay, there's a number, so there's x, and then 5 times, and then 9 more than. That means this isn't an inequality. This is 9 plus. When you see more than, that's plus. So 9 plus 5 times x is 49. Okay, so what do we have to add to 9 to get 49? Well, 40. So what times 5 gives you 40? 8. Okay, so 8 is the solution. The sum, okay, we're going to be adding something, of a number, there's our variable, x, and 12 is equal to 4 times the number. These two things are the same thing. Okay, so we have the sum of a number and 12 is equal to 4 times the number, right? So you're going to plug in the same value here and here. So we need this product to be something bigger than 12, right? Okay. No, I take that back. We need this product to be bigger than 12. All right. So if I plug in a 0, does 0 plus 12 equal 4 times 0? No. What if I plug in a 2? 2 plus 12 is 14, but 4 times 2 is 8. So that doesn't work either. What if I plug in a 4? 4 plus 12, does that equal 4 times 4? Yes, 16 equals 16. So the solution is 4. Sorry. So the solution is 4. They want you to plug in and figure out which ones work, okay? It's going to make solving that much more appreciative. We'll be more appreciative of that. Right? Why don't you hit the pause button, try A, B, and C. This is your set up here. And then when you're done, hit play and see if you got them right. All right, welcome back. We have 16 minus, that means we're going to use a subtraction, 3/4. That's just 3 over 4 of a number. That means multiply. All right, is equals. So I have 16 minus 3/4 of x is 13. Okay. If I plug in a 2, I have 3 times 2 is 6 over 4. I'm only subtracting off 1.5. That's not going to get me to 13. What if I plug in 4? Look at what happens. I have a 4 in the denominator and a 4 in the numerator that cancel. So I end up with 16 minus 3. Well, that's 13. So 13 equals 13, just like that. Example B, 6 more than, this is saying plus, the product of, product means multiply, 3 and a number. A number, that's what we use our variable for, is, there's our equal sign, 12. So 6 more than the product of 3 and a number is 12. All right? What do I have to add to 6 to get 12? I have to add 6. So what do I have to multiply 3 by to have this be equal to 6? 2. So the solution is 2. These are my brackets. Oops. 4 less than, okay, so we have to do some reversing of position. Twice a number equals 16. Remember, twice is 2 times a number. Minus 4 equals 16. So if I'm going to reduce 2 times a number, and I'm going to reduce it by 4, that number better be bigger than 16, right? So I have to use 10. So 2 times 10 minus 4 is equal to 16. This is 20 minus 4 is 16 equals 16. Good job. If any of these you don't understand, play it again and listen carefully to the words and try and improve your understanding by replaying this video. Here's our homework for tomorrow in class. Come prepared, come with your notes filled in, and I'll see you tomorrow. Thanks for listening. Bye.